At this time, we're going to move, because of our time, very quickly to the presentations. So we have presentations from our fellows, and our fellows will be coming up shortly. So I'm going to show this, I'm going to share my screen so that you can see the schedule for our fellows, and then we'll move ahead to the presentations. So these are the presentations, the paper presentations that we have. We have Exploring the Role of AI in Tackling Antifungal Resistance by Divya Sri, Eco Irrigation, Empowering Green Agriculture for Food Security by Mobolu, and so on and so forth. So we have about 1, 2, 3, 4, 5, 6, 7 presentations from our fellows that we would like to take now. So the first presentation will be Exploring the Role of AI in Tackling Antifungal Resistance. Please note that presentation is just 5 minutes, and then we'll move on to the next because of our time. So without further ado, I would like to invite the first presenter, Ravipati Divya Sri. Please feel free to share your screen and also turn on your video. So Ravipati Divya Sri, the floor is yours. Thank you.
Greetings of the day to everyone. I'm Divya Sri Ravipati from India. Today I'm going to present on exploring the role of antifungal resistance in tackling antifungal resistance. So firstly, how AI is reshaping the global healthcare. We can observe the application of AI in different fields, including oncology, genomics, and diagnostics. Oncology, cancer, we can identify the stage of cancer also using AI, and also particularly why AI is because we can identify invisible patterns that we cannot see. We can by using AI we can identify the genetic mutations and hereditary related problems very easily and fastly. We are using AI in different fields of healthcare, be it like arranging hospital bills and etc., and also taking care of health. But we are overlooking antifungal resistance. When people say about any deadly diseases, most people tend to think about viruses or bacteria, for example, tuberculosis or AIDS. We think of that, but there are some fungal diseases which can be deadly. So, why antifungal resistance is a hidden pandemic? According to WHO, FPPL is a fungal priority pathogen list. It released in 2022, which include 19 species of fungi, which includes Candida, Aspergillosis, Streptococcus, and so on fungi. So the mortality rate is greater than 50%. And why we are talking only about fungi here? Because fungi is an eukaryote, which is similar to human cell, and the optimum temperature, that is its favorable temperature, is similar to human human normal body temperature, which makes it very easy for it to stay in the human. And also it can reproduce sexually and asexually. If certain fungi develops the resistance against some drugs, it can pass on that resistance to other fungal species also. Here we have 4 systematic drugs globally. The work is limited in this particular field. Even the fungi can cause deadly diseases throughout. The drugs include polyenes, azoles, echinocandins, and pyrimidine analogs. And polyenes, azoles, most of the fungi are already resistant to these drugs. And azoles include ketoconazole, itraconazole. Most of the fungi are already resistant to these drugs. So why current tools fall short? Gathering data, like traditional method is we isolate a culture, and then there is something called minimum inhibitory concentration. It is like a standard concentration which is followed throughout the globe. If we use that based on the conditions, like their surrounding environment, the place they are living, the fungi may develop resistance. But this is just a standard value. If we include all the fungi under this value, the under this value, then we cannot separate its resistance based on that. Sequencing can be very expensive. So what we are missing, these are what we are missing. Due to limited time, I am going to keep it concise. So the next one is why AI. So what we are lacking is what AI can fill it. So AI can predict resistance beyond known mutations. So I'll be explaining models in the coming slides, which helps us understand how AI can predict the resistance. Integrates genomics plus clinical data, set of dynamic cutoff was static MIC thresholds. Minimum inhibitory concentration, that which I was saying just now, which is stable. AI can consider different factors like the environment, the drugs that we are using, and everything to set a dynamic cutoffs, which helps us develop drugs accordingly. So enable real-time decision support for clinicians. So deadly drugs like deadly fungal diseases like aspergillosis, it is related to lungs, and candidiasis, it enters the bloodstream. So when patients have these diseases, it is important to take decisions fastly, and that should be precise. So AI help us to take the best decisions faster. So I was saying AI can help us tackle this fungal resistance, but how exactly are we expecting? So I'll be explaining that. Firstly, AI. This is machine learning and deep learning. These are parts of AI. So in deep learning is inspired by human, like our brain. So these models, gradient boosting, ensemble learning, multi-grain cascade forest. So all these algorithms come under ensemble learning. So to put it in brief, we can observe the picture here. This is the training data. This is the first model. Here we can observe incorrect predictions. But in the coming one, there are comparatively less predictions. What it does is it uses the previous data and the present data to get the information. Like if it uses the data continuously, by studying the previous data, it can identify the mutation before it comes. By studying the previous fungi before it's developing resistance, we can identify the future, like the fungi before it develops the resistance. These multi-grain cascade forest, it particularly, even if the data is not very well organized, we can identify that. It is like a layered learning. It was mentioned here, you can just go through. So across globe, how fungi is influencing across the globe. Why we are calling pandemic? I've listed all this here. Fungi can be opportunistic. So I've mentioned different countries and their impact. So mortality rate, it is greater than 50%, as I said before. In ICU, oncology patients and AIDS patient, it increases. Apart from AIDS, they'll also get this disease, which increases the chance of getting prone to death. So what is my vision of doing gathering all this work is to transform microbial data into actionable insight that save lives and reduce healthcare burdens and strengthen global preparedness against fungal threats. So I thank Almighty God for His strength and for giving me strength and wisdom, my mother, my university, and then this initiative, the organizers. I thank everyone for the stage, for giving me this stage, and I thank the resourceful people who just gave information, and I thank you all for your attention. Thank you, one and all. Yes, ma'am.
Thank you so much,
Please.
Ravipati, for that wonderful presentation. So I'll be taking over for now. And because of our time, we don't have a question yet. Maybe at the end of the whole session, the presentation, then we can ask
Feel
questions.
free to post your comments. I'll try to answer. Thank you.